Welcome to all here in the session of mathematics. In today's session, we will take three-dimensional geometry, that is equation of the plane. We will take vector form as well as Cartesian form of the equation of the plane, because you have the vector form and Cartesian form in your course for +2 second year. That's why we will take equation of a plane in vector form as well as in Cartesian form. Okay. First we will take the vector form, then we will take the Cartesian form. Suppose you have to ask what is the definition of the plane. First we will take the definition of the plane. I am writing here, you see, that is a plane is a surface. Is a surface such that if any 2 points are taken, any two points on the plane, any 2 points are taken on it, then the line segment joining them, line segment, that means joining these 2 points, lies completely on that surface, that is on the surface. Again you read, that is a plane is nothing but a surface such that if any 2 points are taken on it, any 2 points, suppose you will take one point A, another point is P. So this one is the surface, you see, this one is one of the surface. If you will take any 2 points on this plane and the line joining these 2 points, suppose we have taken A and P, then the line segment AP totally lies in that plane. That means totally line segment AP lies on that surface. Then only you can say this one is a plane. Okay. So plane is nothing but a surface. Okay. So you see here A is a point having the position vector A. Having the position vector A means what? You can write here A having the position vector A. That means if you take origin is here, then OA vector is equal to A. On the plane having the position vector, vector A vector, then OA vector is equal to A vector, is not it? Position vector means what? That is refer to the origin, the position, that means towards the direction of the point A, OA direction is equal to A vector. Now we'll take another point. Let P is a point having the position vector R. That implies OP vector is equal to R vector. You see, OP vector, this vector is equal to R vector. So this is R vector. This one is A vector and this one is R vector. Then you see this one is the normal. Normal means one vector which is perpendicular to the plane. That means if you will take any line, you will take another line, suppose likewise, this vector is perpendicular each of the line segment that lies on that. So now we'll take one of the animation, so you have clear your idea from the animation. Okay. Now to find the equation of the plane, first we will take one n vector in the space. So suppose you have to ask how many planes are there which are perpendicular to n vector. So your answer should be infinitely many planes are there which are perpendicular to n vector, isn't it? Suppose one point. Suppose you have to ask one point A having the position vector A vector. Then how many planes are there which is passes through A point and perpendicular to n vector? So your answer should be there is only one plane. There is only one plane which is passes through the point A, isn't it? And perpendicular to n vector. So your answer should be there is only one plane. So you see one plane is there. There is only one plane which is passing through the point A having the position vector A vector and perpendicular to n vector. Now if we will take another point, that is suppose named by P and whose position vector is R, that means OA is equal to A vector and OP is equal to R vector. That means the plane passes through a point having the position vector A vector and is normal to the vector n cap or n vector. Normal means what? It is perpendicular to the plane. If you will join AP, then you will get one line segment. So n vector is perpendicular to the line segment AP. So AP is equal to how much? Position vector of P minus position vector of A, that is R minus A. So AP is perpendicular to N, that means their dot product is equal to 0. AP dot N is equal to 0, isn't it? AP is equal to R minus A, and R minus A dot N vector is equal to 0, since R minus A perpendicular to N vector. Now from the animation we clear that AP vector is perpendicular to N vector, isn't it? So AP dot N is equal to 0. AP vector dot N vector is equal to 0. All of you know that if two vectors are perpendicular, then their scalar product, dot product, is equal to 0. What do you mean by AP vector? You see, AP vector means position vector of P, that is R, minus position vector of A, that is A. R minus A dot N vector is equal to 0. This equation itself is known as vector equation of the plane. This one can be written as R vector dot N vector minus A vector dot N vector is equal to how much? 0, or you can say is equal to A vector dot N vector. Okay, you can write also this one is the vector equation of the plane. So now we'll take the Cartesian equation of the plane. Okay, now we'll take the Cartesian equation, that is from the vector equation we'll take Cartesian equation, that is R minus A vector, R vector minus A vector dot N vector is equal to 0. Just we have found this is the vector equation of the plane. If A vector means A vector, suppose x1 I cap plus y1 j cap plus z1 k cap, and R vector, that is P point having the coordinate R vector, that is unknown to us, that is xi cap plus yj cap plus zk cap. That means what? x1 y1 z1 is the coordinate of the point A, x1 y1 z1. If the coordinate of the point A is x1 y1 z1, then A vector is equal to x1 I cap plus y1 j cap plus z1 k cap, all of you know. And if the point P is unknown to us, this one is known to us, the coordinate of A is known to us, and this one is unknown to us, and n vector, that is n vector is normal vector, that is if A I cap plus B j cap plus C k cap. Now putting all these values here, that is x I cap plus y j cap plus z k cap minus A vector means x1 I cap plus y1 j cap plus z1 k cap whole into dot product with n vector, that is A I cap plus B j cap plus C k cap, isn't it? That is equal to 0. So R vector here putting, R vector is equal to x I cap plus y j cap z k cap, and A vector is equal to this one, and n vector is equal to A I cap plus B j cap plus C k cap is equal to 0. Now taking from this I taking as common, we have left with x minus x1 into I cap, because taking I as common. Likewise y minus y1 whole into j cap plus z minus z1 whole into k cap, total dot product with how much? That is A I cap plus B j cap plus C k cap is equal to how much? That is 0. So from this I dot I is equal to 1, j dot j is equal to 1, k dot k is equal to 1. So from this we conclude that x minus x1 into A I dot I is 1 plus y minus y1 to B plus z minus z1 into C is equal to 0. So this is the Cartesian equation of the plane. If one point given x1 y1 z1, this one is the equation of the plane. Okay, keep it in your memory, equation of the plane, that is Cartesian form. এই ফর্মটা হি বহুত গুড়াই ইউজ করিও, Cartesian form. एटा यूज करके आमे पूरा प्रॉब्लम करबा वेक्टर फॉर्म टा मन रखियो जेतेबेले दरकार हो कहबी तुमको where x1 y1 z1 be any point on the plane, any point on the plane A, B, C. What is that? DRS. DRS of the normal. Of the normal to the plane. So all of you keep it in your memory. X minus x1 into A plus y minus y1 into B plus z minus z1 into C is equal to 0. This is the equation of the plane in Cartesian form where x1, y1, z1 be any point on the plane. And what is ABC? ABC is the DRS, that is direction ratio of the normal to the plane. बुझी पाइले समस्या normal to the plane तो तुम जानी कोटा normal to the plane. This one is the normal to the plane. So DRS of this, that means here you can write DRS of this normal is A, B, C, and this point having the coordinate x1, y1, z1. This one is known to us. एटा देइथिबो एटा भी देइथिबो ताले इ सूत्र पकेइलो इक्वेशन बाहरी गला. एटा न देइथौ एटा xyz एटा xyz having the coordinate xyz. So unknown रहिबा दरकार ना. If any point whose coordinate is given and DRS of the normal to the plane given, DRS of the plane no, DRS of the normal to the plane is given, that is ABC. Okay, DRS देइथिबो normal रो आउ plane ऊपर गोटे point देइथिबो ताले equation of the plane कोन हला? Equation of the plane हला A whole into x minus x1 by x minus x1 into A plus y minus y1 into B plus z minus z1 into C is equal to 0. From this you can find the general form of the equation. That is already we have x minus x1 into A plus y minus y1 into B plus z minus z1 into C is equal to 0. This is the equation of the plane in Cartesian form. So multiply. So multiply, if you multiply ax minus ax1, simple multiplication. By minus by1 plus cz minus cz1 is equal to 0. Okay. Now keeping ax, by and cz are the left hand side. Ax plus by plus cz plus minus ax1 minus by1 minus cz1 is equal to 0. अच्छा देख लो a b c गोटे गोटे नंबर गोटे गोटे संख्या, that is numerical value. x1 y1 z1 भी गोटे कोऑर्डिनेट गोटे पॉइंट रो सेटा भी गोटे numerical value. ताले एटा गोटे कोन हला कांस्टेंट भारिबोनी. So you can write this equation as ax plus by plus cz plus d, where you can write where d is equal to, you have taken d is equal to how much? That is minus ax1 minus by1 minus cz1. These are all totally constant since a, b, c, DRS of the normal x1, y1, z1, that is one of the coordinate of any point, numerical value. This one ABC is numerical value. So total is numerical value, that is one of the constant. So now we will replace that numerical value by d, that is a constant. So this is the general equation of the plane. तो ये जदि तुम क्वेश्चन करियो हाउ मेनी अननोन्स आर देयर, प्राय पिला कहते सर ए टा अननोन, बी टा अननोन, सी टा अननोन, एकदम ठीक कहते किंतु डी टा जो अननोन कहि दियंती सेटा भूल कहते. कारण एठु आमे बाहर करि परिबा a by d into x plus b by d into y plus c by d into z plus 1 is equal to 0. So how many unknowns are used in the equation of the plane? How many unknowns are used? A by d, b by d, c by d. So short question एठी गोटे note लिख दबो. Note, there are 3 unknowns used in the equation of the plane. Hela? The equation of the plane, equation of the plane contains 3 unknowns. Now we'll take equation of the plane passing through the 3 points. If the plane passes through the 3 points, coordinates are, suppose A having the coordinate x1, y1, z1, B having the coordinate x2, y2, z2 and C having the coordinate x3, y3, z3. Then we have the equation of the plane passes through A having the coordinate x1, y1, z1 each. Already we have found A whole into x minus x1 plus B whole into y minus y1 plus C whole into z minus z1 is equal to 0. This is the equation number 1. Now since x2, y2, z2 is a point on the plane, x2, y2, z2 is a point on the plane, that implies it should satisfy the equation of the plane. So therefore x बदलरे x coordinate, y बदलरे y coordinate, z बदलरे z coordinate you should replace. Why? Since the point is on the plane, that's why the point should satisfy the equation of the plane. Point should satisfy the equation of the plane means you have to replace x by x coordinate of the point, y by y coordinate of the point and z by z coordinate of the point. That is nothing but the a whole into x2 minus x1 plus b whole into y2 minus y1 plus c whole into z2 minus z1 is equal to 0. This is the equation number 2. Now again x3, y3, z3 is a point on the plane. That implies it should satisfy the equation of the plane. That is a whole into x should be replaced by x coordinate. That is x3 minus x1 plus b whole into y3 minus y1 plus c whole into z3 minus z1 is equal to 0. This is the equation number 3. Now solving these three equations, equation 1, 2, 3, you see solving equation 1, 2 and 3 for A, B, C, that is eliminating A, B, C. A, B, C eliminate कर देले आमर इक्वेशन टा कौन होबो कहलो, इक्वेशन टा कौन होबो डिटरमिनेंट स्टाइल पढ़ी थिला, that is nothing but the coefficient. First equation रे रो coefficient केते अछि x minus x1, so you should write here x minus x1, and second equation रे रो coefficient x2 minus x1, and third equation रे रो coefficient x3 minus x1. Do you follow or not? Then b रो coefficient y minus y1, that should be in the second column, so y minus y1, y2 minus y1 and y3 minus y1. Okay, the coefficient of C here in the first equation, second equation, third equation, that is z minus z1, z minus z1, z2 minus z1 and z3 minus z1 is equal to 0. So which is the equation of the plane passing through the 3 points x1, y1, z1, x2, y2, z2 and x3, y3, z3. Okay, this is the required equation. Is the required equation of the plane passes through 3 points x1, y1, z1, x2, y2, z2, x3, y3, z3. Now we will take some problems of the exercise which is related with the equation of the plane passes through the 3 points x1, y1, z1, x2, y2, z2 and x3, y3, z3. Okay. Now we will start the problem of the exercise 13b. Okay. So you read the question number 3, that is find the equation of the plane passing through the points B1 is given 6 minus 1 1, 5 1 2 and 1 minus 5 minus 4. So the plane passing through the 3 points given, that means we know that formula, determinants type formula. So first you will write, given the plane passes through the 3 points, plane passes through the 3 points or first one is 6 minus 1 1, that one you can take x1, y1 and z1. Okay, and second one is 5 1 2, and that one is you can write x2, y2, z2, and third one is 1 minus 5 minus 4, that one you can write, that is x3, y3, z3. Now the equation of the plane you can write here. The equation of the plane passes through the 3 points is, that is in the determinant style. All of you know that is first row is x minus x1, y minus y1 and z minus z1. Then second row is x2 minus x1, y2 minus y1 and z2 minus z1. And third row is x3 minus x1, y3 minus y1 and z3 minus z1. Okay, this one is equal to 0. So this is the equation of the plane passes through the 3 point x1, y1, z1, x2, y2, z2 and x3, y3, z3. So already now you can replace this value. So this is nothing but the, that is nothing but the x minus 6, y plus 1 and z minus 1, first row. Second row 5 minus 6, x2 minus x1, 1 plus 1, only replacing the value, 2 minus 1. And third row is 1 minus 6 and minus 4 minus 1, minus 4 minus 1 is equal to 0. Okay, so you can evaluate this one expanding, that is nothing but the x minus 6, y plus 1 and z minus 1, first row. Second row is minus 1 and 2 1. So you can expand yourself, that is x minus 6 whole into 2 into minus 5, that is minus 10, minus minus plus 4, minus y plus 1 whole into plus 5 plus z minus 1 whole into plus 4 minus minus plus 10 is equal to 0. Okay, that is x minus 6 whole into minus 6 minus y plus 1 whole into 10 plus z minus 1 whole into 14. So that is nothing but the minus 6x minus 10y minus 6x plus 36 minus 10y minus 10 plus 14z minus 14 is equal to 0, or in other word minus 6x minus 10y plus 14z plus 12 is equal to 0. Dividing minus 2 both the sides, you will get 3x. This is nothing but the minus 2 dividing, so 5y minus 7z, 6 is equal to 0. So that is the equation of the plane passes through the 3 points which are given. Okay, so only you will take that formula, then you can find with the determinant, expanding this you can find the equation of the plane. Okay, that's your answer. Now we'll take some notes before going to the problem number 4. Okay, so all of you know that there are 3 coordinate planes. One is xy plane, another one is yz plane and third one is zx plane. Suppose you have to ask what is the equation of the xy plane. All of you know that any point on the xy plane whose coordinate is looks like xy 0, that means z coordinate should be 0. So that's why the equation of the xy plane is z is equal to 0. Okay. Likewise, the equation of the yz plane is x is equal to 0. Why? Since on the yz plane, every point having the coordinate, x coordinate should be 0. That's why the equation of the yz plane is x is equal to 0. Similarly, the equation of the zx plane is y is equal to 0. Suppose you have to ask what is the equation of the plane which is parallel to the xy plane and at a distance a unit from the origin is, what is that? One diagram you see, suppose this one is x-axis, this one is x axis, this one is y axis and this one is z axis. one plane is xy plane, okay, and this one is the plane which is parallel to the xy plane but at a distance a unit from the origin. That means z is equal to a. 2 dimension नहीं ठीक से बड़े 2 dimension नहीं केमती हेतांता 2 dimension नहीं तुम्हारा देखो suppose एठी गोटे लाइन टे अछि, suppose this one is x axis x dash and this one is y and y dash and this one is origin. This part is a suppose. So this coordinate is 0 a. ताले ए लाइन रो इक्वेशन कोन कोतलो y is equal to a मन पड़ला. Since this line is at a distance a units from the origin, that's why the equation of this line is y is equal to a. So likewise in the 3D, since this plane is parallel to the xy plane, so at a distance a units from the origin, so z is equal to a. Why z is equal to a? Here you see y coordinate, y is equal to a because parallel to x axis, parallel to x axis माने x टा काटी देबो, y is equal to a. এটা parallel to xy plane माने xy काटी देबो, z is equal to a. Okay, concept बुझिला पूरा मन रहइबो. So likewise the equation of the plane parallel to the yz plane at a distance a, yz plane अछि माने x is equal to a. Parallel to the xy plane अछि माने z is equal to a. Same parallel to the zx plane अछि माने y is equal to a. Now we'll take another important note, that is the equation of the plane parallel to the plane ax plus by plus cz plus d is equal to 0 is nothing but the ax plus by plus cz plus k is equal to 0. That means what? Suppose you have to ask what is the equation of the plane parallel to the plane ax plus by plus cz plus d is equal to 0. ताले कौन करियो? पूरा simply ax plus by plus cz लिखिबार अछि, पूरा same लिखि दो, only changing d place, constant place should be changed. Here constant is d, here the constant is k, and where k is to be calculated. Okay, k रो value टा calculate करियो अब गोटे source देथियो, जेमति हला गोटे given condition देथियो k रो value बाहर करिया पई, k रो value बाहरी गले k रो value put कर देले equation of the plane पाई गलो which is parallel to the given plane. diagram टा देखो, suppose one plane is there whose equation is ax plus by plus cz plus d is equal to 0, plane 1, and his normal is what, n1 suppose, which is perpendicular to the plane. Normal माने कोन, which is perpendicular to the plane 1. So यार DRS केते a b c. तमे DRS of the normal जेतेबेले पचारि जीवो what is the DRS of the normal to the plane, then your answer should be coefficient of x, coefficient of y, coefficient of z. That is a b c. Okay, this is the DRS of the normal to the plane. Likewise, suppose this plane 2 is parallel to the plane 1. That means equation of this plane should be ax plus by plus cz, only changing d part. Here d, here should be k. And the DRS is a, b, c. So a, b, c. Since they are proportional, a by a is equal to how much? 1. b by b is equal to 1. c by c is equal to 1. So they are equal. So we know that when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then L1 is parallel to L2. When the normal to the planes are parallel to each other, then the two planes are parallel to each other. So now we'll take number 4 of exercise 13b, which is related about these nodes. Okay. Now you read the question number 4b. Find the equation of the plane passing through the point 2, 3, minus 1 and parallel to the plane this one. So do you know what is the equation of the plane parallel to the given plane? जदि given plane गोटे देइछि तार equation देइछि तार parallel जे हबो ता माने a1 by a2 is equal to b1 by b2 is equal to c1 by c2 हबा दरकार. ताले सेम जिंस लिखि देइकि खाली d टा चेंज कर दो. Okay, so now we'll take the solution. First you write the given condition. So given equation of the plane, that is given 3x minus 4y plus 7z is equal to 0. You can write here any plane parallel to the given plane, parallel to the, you write this equation is 1, parallel to the given plane 1 is, what is that? Write same thing, 3x minus 4y plus 7z plus k is equal to 0. What is k? K is unknown to us. Since parallel, you see, parallel means amar eta satisfy koriya darkar. A1 by A2, 3 by 3 is 1. minus 4 by minus 4 is 1, 7 by 7 is 1. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. যদি এটা satisfy কলা টু প্লেনস আর পারলা এটি ডি টা কোন আছে এটি ডি কোন আছে আমার জানিবা দরকার নাই তেনু খালি ডি যদি চেঞ্জ হই গলা প্লেনটা এই দুইটা প্লেন যাক প্যারালাল হবে বলি জানি রাখো তাহলে যে কোনসি গোটে প্লেন র ইকুয়েশন দেইছি তার আউ গোটে প্লেন ইকুয়েশন পচারছি আর সেটা প্যারালাল আছে মানে সেম ইকুয়েশন লিখতে খালি ডি টা চেঞ্জ कर दो तो এই ডি বাহার করিয়া পাই টু ফাইন্ড द ভ্যালু অফ ডি ওয়ান সোর্স ইজ गिवन that is the plane passes through the point 2 3 minus 1 since the plane passes through the point 2 3 minus 1, okay, then it should satisfy the equation of the plane. The equation of the plane this point lies on this plane means what? So x coordinate, here the unknown variable x should be replaced by this x coordinate and y should be replaced by y coordinate and z should be replaced by z coordinate of the point. Then only the point satisfied the equation of the plane. That means the point lies on the plane. So therefore we write here 3 into here x should be replaced by x coordinate 3 into 2, okay, minus 4 into y should be replaced by y coordinate that is 3, okay, plus 7 whole into z should be replaced by z coordinate that is minus 1 plus k is equal to 0. So you can find the value of k. So 6, this one is 6 minus 12 minus 7 plus k is equal to 0, or in other word k is equal to, so k is equal to 13. So from this we have found k is equal to 13. Now by putting k is equal to 13 you can find the equation of the required plane. So the equation of the required plane is how much? That is 3x minus 4y plus 7z plus 13 is equal to 0. He is asking find the equation of the plane passing through the point this parallel to the plane this. That means a plane sanger जे parallel तार equation कौन होगा 3x same equation लिखियो only d टा change कर दो constant टा, okay, सही constant र value बाहर करिया पे गोटे source थिबो निश्चय. So the point is given, से point x coordinate x जगह put करो, y coordinate y जगह put करो, z coordinate z जगह put कर दो. So you can find the value of k that is unknown. So now replacing the unknown variable you can find the equation of the plane, okay. So that's all for the today's session. In the next session we will take from number 4 bit b, okay. So until then, goodbye, thank you.